Today, we're going to be taking a look at some other developments in arts and crafts architecture, uh, continuing our look at Green and Green, specifically their work at the Gamble House, and then we'll take a look at some other things that were happening about the same time, but that aren't in a direct line of development from arts and crafts. Certainly related to arts and crafts and have some common elements to them and some common sources, but began to develop in some slightly different ways, specifically Art Nouveau and also the Chicago School. Now, when we took a look at some of the developments in arts and crafts, we saw the way that Voisey developed upon arts and crafts in a very personal way. The way that he took sort of an anonymous Northern European vernacular architecture and developed it with some quirky proportions, some quirky details, all of it as a way of turning it into his arts and crafts. And sort of bringing it forward in that way. And what he did ended up providing a model for residential architecture in the United Kingdom through World War II and even beyond, even in the years after World War II. In addition, we also took a look at the way that the West learned about the tradition of timber construction in Japan. And we saw the importance of traditional Japanese architecture for arts and crafts architects. They saw this as an ideal craft tradition, not something that was only limited to imitation by architects in the particular area. Vernacular architecture that was such a strong, important source for arts and crafts architects is always strongly regional in terms of the materials that are available, the climatic conditions that are responded to, the development of traditions. But the vernacular timber construction of Japan seemed to be an ideal craft tradition that architects around the world could sort of tap into and imitate and draw inspiration from. It was considered ideal because of the respect for the basic materials, the way that you could understand what materials were being used, how they were assembled into the whole, and the way that the structure worked in these buildings. And also, there was something really interesting about the flow of spaces that was achieved in these buildings, a way that those screened partitions could close off a space or open up one interior space to the next, or perhaps the interior to the exterior, and the way that the buildings and the spaces within the buildings would connect to the gardens. All of this was going to provide a lot of inspiration to Western architects. And nowhere do we see that more profoundly than in the architecture of Green and Green. Now, I touched upon their background a little bit. They had some training in both arts and crafts principles as well as in the principles of academic classicism. They were able to see firsthand an example of traditional timber construction of the Japanese architecture at the World Columbian Exhibition in Chicago in 1893. They hadn't traveled to Japan, but there was an example of Japanese architecture built in Chicago for the World's Fair, and they were able to see that. They continued on their way to visit their parents in the Los Angeles area in the early 1890s and realized that there was the need for architects there, for designers there. And so they started taking on some commissions that summer and just stayed in the Los Angeles area and continued to design buildings and made a career for themselves in their architectural firm. Now, when we take a look at the buildings that they did design, we can see pretty clearly the strong influence of traditional timber construction from Japan. Even though none of the details are a slavish imitation of Japanese architecture, there was a great degree of creativity in the details that they came up with, but still, there is this attention to allowing the viewer to understand what the materials are, how they're being assembled, and how they work structurally in the building. And they popularized a building type that became known as the bungalow. And this became a residential type in American architecture up until World War II. So just like Voysey set the standard for domestic architecture in Britain, so Green and Green, to a degree, set a standard for domestic architecture in the United States. And nowhere do we see a better example of the bungalow house than in the Gamble House that Green and Green designed in Pasadena. The Gamble House was for a wealthy family from Cincinnati who decided to purchase a plot of land in Pasadena, a part of the growing Los Angeles metropolitan area, and make this their winter home. And they got Green and Green to come and to design the house for them. Now, when we take a look at the house from the street, as we're doing here in this view, it pretty clearly fulfills many of the criteria that we saw for a bungalow. It's relatively low in elevation. It's got those deep overhangs. It's got exterior spaces that open up to the interior. Good example of a bungalow. But it's really in the rear elevation to the back of the building that we can really see the full extent of the way that Green and Green took inspiration from Japanese architecture. Here we can see all sorts of sleeping terrace or sleeping porches up on the second floor, covered terraces on the ground floor. We can see the way that the garden design and the architectural design interact one with the other, all drawing inspiration from Japanese architecture. We can see the materials that are being used, see the creativity in the details of the assembly of the materials, and we also understand how these individual pieces of materials are coming together in a structural system in the building. Again, all inspiration from traditional Japanese architecture. The building itself is not overly huge. It's a good sized house, but considering how wealthy the Gambles were, they could have asked for a much grander house. They could have asked for something that was much more imposing in its architecture and much larger in its interior spaces. We would go into the house today, and from our perspective, we would see this as ample. Some of the spaces seem a little small, maybe the kitchen or maybe some of the bedrooms might seem a little small, but the house itself is something that we would think of as a domestic scale in architecture. It's not particularly huge. If we were to walk in the front door and take a look at the hallway and the way that that space sort of slides into the living room, which we can see in these images here, we might think that the entry hall is a little large, considering what it's used for, but the way that one space flows into the other would not strike us as anything out of the ordinary. However, for the point in time in which this was designed and built, this openness of one space to the next was something that was noteworthy and was something that was pretty new and different. It's very different from the traditional Western way that you would have one enclosed volume for one function that would then connect to another enclosed volume for the next function, all following on the tradition. And many of those decisions would result, or well, did result from the climatic conditions in Northern and Western Europe and the need to partition the spaces in order to control the temperature within the spaces. In Northern Europe in particular, before the introduction of central heat, really the only way that you could heat the spaces was by keeping them low, small in area, and enclosed, one separated from the next. But here we can see things that are different. We can really see the hallway open up to the living room and one space begin to flow into the next. Now, granted, in Southern California, you really don't need to be worried about the climatic conditions so much. I mean, it's perfect temperature all the time. But we see this one space opening up to the next. We see this change to the traditional way of developing domestic architectural spaces, not only here, but throughout North America and Western Europe. And on the one hand, it is the result of the new possibilities that were available because of central heat and the change that that made to the houses in the northern part of the United States, in Canada, and in Northern Europe. But it's also the result of some of the inspiration that came from traditional Japanese architecture and the way that those screens could be pulled out of the way so that one interior space would connect to the next. Here we can really see the influence of it in the way that the hallway opens up into the living room here. Excuse me. If we take a look at other parts of the interior in the Gamble house, we're going to see details that were very carefully worked out between the architects and the craftsmen. And we can imagine them coming together and discussing the way that the different woods were going to be used in these systems that would allow these different details to speak about the assembly and also the structure of the building. We know that they very carefully selected various sorts of woods for the different texture and for the different color that they would bring. And we know that for many of these details, Greene & Greene sat down with the craftsmen in order to work out how these things were going to come together. And so here we see a great example of an arts and crafts building being designed not just by the architects, but actually by a whole team of craftsmen and architects working together for the details. And furthermore, we're seeing something that in many ways can be considered a total work of art. Not only do we have the frame of the building worked out and designed, and some of the built-in pieces, such as the built-in seating that we can see here in the hallway. But there was also furniture that was designed. There were side tables, dining room chairs, the case for the upright piano, the glass in the front door to the building. All of this was being worked out and designed, and in many ways it is a total work of art, a complete designed environment that Greene & Greene provided to the Gambles. So here we can see another great example of arts and crafts architecture, but we can also see a wonderful example of the influence that traditional timber architecture from Japan had on Western designers. The art that was coming out of Japan was also going to influence the art and architecture of Western Europe and North America in a rather surprising way. Here we're taking a look at two different landscape paintings, the top one being done by a Japanese artist, the lower one being done by a French Baroque painter. Now, if we take a look at both of them, we're going to notice some rather stark differences between the two. The landscape painting designed by the French Baroque painter is going to attempt at a level of precision and legibility that really begins to border on a sort of photographic-like image. It's trying to be realistic to the greatest degree possible. If we take a look at the Japanese landscape painting, we're going to see something that is not aiming at realism to the same degree. There's a lot left in the Japanese painting that is suggested as opposed to very carefully delineated and worked out. And furthermore, there is a stylization that's brought to the depiction of the plants and the topographical features that is a little bit different than what we see in the French Baroque painting down below. And even though the French Baroque painting does not have the perspectival construction that is so strongly expressed as in other examples of painting from the era that we can see, there still is a perspectival framework behind the overall composition there. It's hidden, it's not blatantly apparent, but it's still there. The painting tradition in Japan didn't have the process for laying out a perspectival scene that had become the backbone of painting in Western Europe from the time of the Renaissance on. And so the way that they're going to depict depth and space in their paintings is going to be pretty significantly different. Here we're taking a look at two other examples of painting that was done in Japan before Japan opened to the West in the 1850s. And if we take a look down below, this is a woodcut that has been given color with watercolor washes. We're going to see that there is a suggestion of depth. You definitely know what's in front of other things, but it's more because things are layered rather than a perspectival scene that's being worked out in the ground plane, which here obviously doesn't exist. Excuse me. Rather than a perspectival scene that's worked out in the ground plane, it's more there's sort of layers. One layer of waves is in front of the other layer, which is in front of the other layer, which is in front of the mountain in the background. And in that way, we know what's in front and what's in back, right? If we take a look at the painting in the upper right, we see a very ambiguous ground plane there. We don't have any of the features on the ground plane, nor any of the shade and shadow that would allow us to understand the angle of the ground plane or the slope of the ground plane. Furthermore, the tree and the relationship of the tree to the ground plane is a bit abstract. Again, we don't have any development of texture or shade and shadow that's allowing us to understand how those two connect. And the surface of the water is abstracted into this stylized pattern. And all we have is a line that separates the surface of the water from the surface of the ground without any indication of the ground plane rising above the level of the water, right? There's a lot of ambiguity there. A lot of these techniques ended up inspiring artists in the West, and they ended up drawing some of them into their own compositions. Here we're taking a look at a couple of book illustrations by a British graphic designer from the 1880s, 1890s. And we can see how he incorporated some of those lessons from the traditional arts of Japan into his own work. First, let's take a look at a couple of the figures. The figure on the image to the left with her back to us, the figure on the right who's kneeling. In neither case do we have the development of a texture to the fabric that is clothing the figures, nor do we have development of shade and shadow that allows us to understand the anatomy of the figures. Instead, the clothing over the figures becomes flat and abstract in a way, and we can only surmise the anatomy through outline, basically. If we take a look at the connection of the figure to the right to the ground plane, or the connection of the ground plane to the water surface, again, very abstract, not developed with texture, with shade and shadow. And so the depth and the perspective there is very ambiguous. What we do see is that there is an attention to the decorative quality of the line. If you take a look at the details from the headdress of the figure on the left, which appear to be sort of shaved peacock feathers, if you take a look at the swoop of some of those extended feathers, very refined, but it's about the decorative quality of that line. If we take a look at some of the ripple patterns on the surface of the water on the right, or if we take a look at the gore that is coming out of the decapitated head on the right, and the way that it's coming down to the water, again, the decorative quality of the line is what is being emphasized here. And all of these things are going to lead into a design style in the decorative arts that we know of as Art Nouveau. Largely, Art Nouveau was in the decorative arts, and it was a commercial style that became very popular in the 1890s, 1900s. Some of the earliest examples can be seen in the graphic designs in the decorative arts from Belgium and France, but it very quickly spread throughout Europe and into North America. And here, if we take a look at these two examples of advertising from the era, we can see the abstraction. If you take a look at the figure on the left, we don't see any shade and shadow that allows us to understand where the jawline of that woman's face is. Rather, what we get is the profile and the outline of her face and her neck. The line quality that the artist was able to develop with her flowing hair and with the cigarette smoke is part of what's making this such an interesting graphic. And on the right, again, we can see the graphic quality of the line there in this scene with the figures that have a very ambiguous relationship to the ground plane or to the background. So we can see it in advertising. We can see it in some of the decorative arts, in vases, in picture frames, executed in a variety of different materials. And if we take a look at Art Nouveau, we will see that there were some standard subjects that were sort of the favored subjects over and over and over again. We can see peacock feathers. We can see tall women with long hair. We can see water lilies. We can see dragonflies. And all of these subjects were vehicles to develop that line quality, to get the whiplash line and to really accentuate that. So it's a very interesting development upon the inspiration that came from the arts out of Japan. But how did it find its way into architecture, and in what way did it affect architecture? Certainly, the capability of iron and steel to be molded into different shapes was going to provide an opportunity for designers to pick up on some of the inspiration from arts and crafts and bring it into structure. And here we're taking a look at some of the metro stops in the city of Paris, which are beautiful examples of Art Nouveau in iron and steel. Probably the architectural highlight is in the Tassel House, designed by Victor Horta, who was a Flemish architect, spent significant amounts of time studying in classical academies in Brussels and in Paris. And in his design for the Tassel House, which is a townhouse in Brussels, we can see the way that he developed the mosaic tile pattern of the floor. We can see the way that he developed a stencil pattern for the walls. We can see the way that he designed structural connections for the structural support here to the iron framework for the staircase, and the way that he turned all of that into an opportunity to really express that whiplash quality of the line. Designing some things like the handrail and the balusters, selecting other things like the light fixture, which is hanging here. But if we take a look at the exterior of the Tassel House, and if we take a look at the plan of the Tassel House, we're going to see something that in many ways is a very traditional, very classical design. Take a look at the floor plan there. The row house is just a very narrow site within a much larger block. And the entrance is right in the center of the site for the house. You enter in the center, you move through on a central axis, and the spaces that you move through are these enclosed volumes that are based on basic geometric shapes. All a very classical way of laying out the building. On the exterior, we can see that central axis that rises vertically on the facade of the building. And on the exterior, it's really not that different from the townhouses on either side. So it's very much a very traditional building in many ways, but it's in the decorative arts on the inside of the building that we can really see the full expression of Art Nouveau. This was pretty typical for Art Nouveau. In many cases, we can see that it's decorative. In the example on the left, also an example of Horta's architecture, we can see an octagonal space that's right in the middle of a townhouse, articulated with very thin steel structure here. But we can see that in his hands, the steel and the glass skylight are an opportunity to draw inspiration from natural forms and to turn it into an Art Nouveau expression. Now, having said that, there are some other examples where we can see Art Nouveau really inspire space and structure that's much more creative than other things that we've been taking a look at. If we take a look on the right, another space designed by Horta, we can see a design of the space that is not your typical basic geometric volume. It's much more creative. It's much more free-flowing in a way. And the structure here is even more creative than the structural elements that we've been taking a look at in any of the other examples of Horta's work. And so Art Nouveau did open the door to some real exploration of structure and space that other designers just were not paying attention to at the time. But it's interesting to see the way that some of the qualities of Japanese art inspired Western graphics, inspired Western commercial art, Western decorative art, and eventually Western architecture in this way. And it's also interesting to note the connection to history, because Art Nouveau was a decorative style that was not overtly drawing inspiration from classical Greece and Rome. It was not overtly drawing inspiration from medieval Gothic architecture or even any of the traditions out of Eastern Asia or other parts of the world. Yeah, we can trace its lineage back to some of the qualities of Japanese art, but if we take a look at Horta's design again on the lower right, this doesn't look like a Japanese building, right? And so this is a design style that begins to shake off the shackles of connections with architectural history. And in that way, Art Nouveau really opened the door to other explorations later. So keep this in the back of your mind. This is going to be a very interesting beginning to an architecture that is non-historical in its architectural expression. But we're going to have to take a look at some of the architectural developments in the United States, and in one particular city in the United States where things came together in a very particular way and in a very creative way, and that is in the city of Chicago. Chicago today is one of the largest cities in the United States. If we take a look at the map, it's right on Lake Michigan at the lower end of Lake Michigan, sort of down by the lower part of the curve off to the left in Illinois. And if you take a look at the image on the to the left there, you're going to see how the center of the city, how the commercial district of the city is built right up on the lake shore itself. And the city sort of spreads out north and south from that center of the city, which is called the Loop, north and south, and extends inland into suburbs that extend into the beginnings of the prairie, which is right there at in northern Illinois. The city itself has had its foundation as a French trading post. It's located at the mouth of the Illinois River as it flows into Lake Michigan, and it was a French trading post. And then as the new United States began to acquire more and more territory, it began to be a trading post and then a transportation center in what had been called the Northwest Territories of the United States. The Great Lakes states, Ohio, Indiana, Illinois, Wisconsin, Michigan. New territory that was added on to the original United States, and that little by little began to organize into a variety of different states. Chicago became important because of the natural resources that were in very close proximity to it, but also as a trading center. Um, Before railroads became common in the United States, a lot of the transportation was done either on the Great Lakes, which were these open waterways which could be plied by very large freighters, or by the river system, or by canal systems that connected the rivers to the lakes and that allowed goods to be taken from the Northwest Territories to the large industrial and population centers on the eastern seaboard of the United States. And this was going to become increasingly important as the new United States acquired more territory in the center of the continent and as it began to develop the plain states and the agriculture in the plain states, as it began to develop the mountain states and some of the raw materials that were coming out of the Rockies, all of which needed to be transported to the population and industrial centers on the eastern seaboard, and so needed to be carried across the plains and through this network of rivers and canals and lakes. Eventually, as railroads became more common, Chicago became a railroad hub, and a lot of the food stuff that was coming out of the plain states, a lot of the raw materials that were coming out of the Great Lakes area and the Plain States and the Rockies all came through Chicago on their way east. And Chicago grew exponentially in the 1840s, 1850s, and 1860s. And it became one of the most important transportation centers, as well as one of the most important business centers in the United States. In October of 1871, there was a fire that broke out in southern Chicago that very quickly spread and that consumed all of the commercial center of Chicago, as well as large segments of the residential area of Chicago over 3 nights. The Great Fire of Chicago. Supposedly, it was started in the shed behind Mrs. O'Leary's house when her cow kicked over a lantern that set the hay on fire, that set the shed on fire, that set Chicago on fire. And at the end of 3 days, there was more than 3 square miles that was burnt in the fire. Over 300 people died in the fire, and there were over 100,000 people that were left homeless. The devastation was immense, and it really became a question what was going to happen next. But very quickly, the people in Chicago dusted themselves off, picked themselves up, and started cleaning up and rebuilding. This was one of the most vigorous reconstruction programs ever seen, and it drew upon the ethos of this city that had been growing by leaps and bounds before the fire, and that was determined to show the rest of the world, almost as a sort of a collective civic ethos, that it could pick itself up and rebuild. And very quickly, Chicago made a name for itself, and the reconstruction that we're going to see here is really evidence of the energy and resilience of the people in Chicago. It's going to make a name for itself as an all-American city. And if the cities on the East Coast, the big old cultural centers on the East Coast, Boston, New York, Philadelphia, Baltimore, and even Savannah and Charleston, if they seem to be tainted by their colonial foundations and continued connections with Europe and with Great Britain, Chicago in many ways is going to seem like the all-American city. And the people here had a forward-looking approach to things that meant that they were going to be quite happy to allow for a degree of experimentation here in all sorts of ways that other people on the East Coast of the United States might not have. And that's going to affect the architecture in a very strong way. whereas building patrons and designers on the East Coast might be more conservative in their approach to things. While they might be more tied to the European traditions, in Chicago, the building patrons were not so tied to the traditions, and the architects and the designers who came to Chicago were much more open to exploration and new influence. And that is going to leave its mark on the architecture of Chicago as it rebuilt after the fire. And the rebuilding is going to start very quickly, and it's going to continue and develop and then redevelop very fast. And so through the 1870s, 1880s, 1890s, we can see a variety of things come together in a very particular way in Chicago that is going to mean that there's going to be a Chicago School of Architecture, something that is very distinct from the architecture that we can see anywhere else in the United States or anywhere else in the world for that matter. But we're going to have to take a look at the way that individual things came together in a particular way here. On the one hand, we're going to see that there were a lot of arts and crafts ideas that were going to get incorporated into some of the architecture that we're going to see here. But we're also going to see that a lot of the reconstruction was going to be of office buildings. And this is a new building type that is going to demand a little bit of discussion at this point. If we take a look at architectural history, we're not going to see any ancient Egyptian office buildings. We're not going to see any medieval European office buildings. We're not going to see any office buildings in Mughal India, right? And so there are no historical prototypes that are going to provide a one-to-one correspondent to the sort of building that is required here, right? And so it's a new building type. It's something that in many ways is the result of the economic development that came with industrialization and colonization. All of a sudden, we see the development of businesses and furthermore international businesses. We can see the need for the concentration of office spaces in business districts that are often connected to industrial centers. As those business districts grow and develop, the cost of property rises. And so the property owners are going to want to maximize the return on their investment, which means that they're going to want to build taller on their sites. This was going to be made possible by some of the new materials that were coming out of the factory, specifically iron and glass, and eventually steel and glass, and the way that you can mass produce structural elements, have them shipped to the site, and then very quickly assembled into the building as a whole. But over the years, through the 1830s, 1840s, 1850s, we also see the exteriors of the building being mass produced, shipped to the site, and very quickly assembled. And those exteriors often were of individual elements that imitated traditional architecture. For example, if we take a look at these two images of different iron front office buildings from the middle of the 1800s, we're going to see things that draw very clearly upon Western classical architecture, and in many ways even palace architecture of the Italian Renaissance. But these forms are not created with stone. Rather, they are mass-produced pieces of iron that were selected out of a catalog, ordered, mass-produced, shipped to the site, very quickly assembled onto an iron frame on the interior of the building. As things grew and developed, as engineering developed, they could make these buildings taller and taller and taller. And so, they could really maximize the property investment that the property owner had on the site. But then you have to inhabit these buildings. Before the introduction of elevators, you could assume that people might be able to walk up 5, maybe 6 flights of steps. But with the introduction of elevators, you can make these buildings go as tall as they can stand. But elevators require technology, they require electricity, that requires an infrastructure and utilities. All of these systems are coming together, all of these developments of technology are coming together in such a way that means that these buildings can grow taller and taller and taller. And then when you inhabit these buildings, you need to provide heat, you need to provide light, you need to provide sewage and plumbing to the different floors in the building, or else it's going to be uninhabitable. And again, we can see this connection of the development of technology, the development of civic utility systems, the sewage systems, the water systems, the electrical systems, all of which are coming together so that these buildings can be accessed and inhabited. And so we see the development of these tall office buildings. Now, when we take a look at the development of these buildings, whether it's in the lectures connected to the architecture in Chicago or later on, there are going to be a few specific questions that we need to ask. And let's take a look at these important questions for tall office buildings. First of all, we're going to have to ask, what is the structural system for each of these buildings? Secondly, is there an expression of structure, or is it represented somehow on the building? And then thirdly, is the design guided by theory, or is there some non-theoretical aesthetic criteria? Okay. Number 3 here in particular may seem a little vague, but as we proceed with the lectures in the course, you're going to understand better that question. But let me just present these 3 questions here, and we'll be coming back to these in today's lecture and also in future lectures. But all of this is going to come together with a degree of creativity that was appreciated in Chicago, and with the development of a local arts and crafts, all of which is going to merge and converge in what we can call the Chicago School. So it's getting complicated, right? We don't have a pure arts and crafts or a pure rationalism, but things are going to come together in a very particular way in Chicago in the years after the fire. And one of the early examples that we can take a look at is designed by William LeBaron Jenney, the first Leiter building. And Jenney was not a trained architect. Rather, he was someone with technical training and someone who had worked for a number of years as an engineer. He studied science at Harvard University, and then upon graduating, he went to France and enrolled in a technical school in France. So he did not enroll at the École des Beaux-Arts. Rather, he enrolled in a technical institute in France and got a technical degree there, came back to the United States, began working as an engineer, served in the armed forces during the Civil War as an engineer, and then had a career on the East Coast as an engineer after the Civil War. But as an engineer on the East Coast, he was very much constrained by some preconceived ideas about what it is that engineers should do and what it is that engineers should not do. And in a lot of ways, he wasn't able to explore some of the ideas that he had about building. But in the years after the fire in Chicago, there was the need to rebuild, there was the opportunity to explore, and he came to Chicago, opened up a firm, and ended up designing a number of buildings, one of the earliest of which is the first Leiter building that we're taking a look at here. Now, let's take a look at the floor plan of the first Leiter building and a schematic view of a typical structural system from the 1870s. If we take a look at the plan on the right, we're going to see that the interior of the building is very clearly a point load system. And the point load system on the interior is going to be of iron columns that connect to exterior masonry. Now, to the right and to the bottom of the plan, you're going to see that those are masonry piers. The other parts of the plan, the left and the top of the plan, have load-bearing masonry walls. In many locations, those were party walls with other building sites on the same city block, and so you couldn't have a lot of openings, right? But But basically, we can see a point load system connecting to exterior masonry piers where it's possible. Now let's take a look at the diagram on the left here, and we can see what the structural system here looked like to a large degree. Right? Point load system of iron columns that are connecting to iron girders and iron joists. And then spanning between those iron joists, we can see these low brick vaults, all of which is going to be covered with concrete fill. And take a look at the tie rods that are spanning from one of those iron joists to the next. Those brick vaults are going to exert a lot of outward thrust just because of the geometry and because of the nature of vaults. How are you going to contain that outward thrust? Well, one vault is going to counteract the other to a large degree, but the tie rod that we see here, which is going to be an iron, is going to be thrown into tension by that outward thrust of the vault. And iron, which is good in compression and to a degree good in tension, is going to be able to counteract that outward thrust and do so by the tension kept within those tie rods. And so this was very similar to the system that we can see here in the first Leiter building. If we take a look at the exterior, we're going to see a building that has relatively little architectural detail here, and certainly no architectural detail that is overtly classical, Renaissance, Gothic in inspiration. We can see exactly where the structural piers are, and in the infill between those structural piers and the floor levels, you're going to see the mullions between the operating windows that are very clearly non-structural. Now, let's back up and take a look at that, the typical office building that we just took a look at. If we take a look at the lower left here, you're going to see that it appears that we've got structural piers on a fairly regular basis here. And indeed, the structure is connected to individual piers on the lowermost floor of the building. But once we get to the inside of the building, we would see that not every one of these exterior piers that are seen on the ground floor connects to interior structural piers. Rather, what we have here is some confusion about what's actually connecting to the interior structure and what's not. There's a repetition of the exterior forms, some of these which are actually structural, some of which are not. Here, however, we know exactly where the structure is, and any other division that's required for the operating windows is very clearly non-structural. If we take a look at the uppermost part of the building, we can see something that's worked out as a cornice in the brick detailing, but the cornice is not proportional in any classical sense to the rest of the building. If this were a classical building, the cornice would be much taller because the proportions of it would need to visually work out with the classical system for the elevation of the building. But that isn't what Jenny was interested in doing here. He didn't want to put a cap on the building that was anything other than what was necessary, even though because of the construction process in brick, you could enliven it a bit. So there certainly is some detail here, but basically it's a very frank expression of the architecture or of the structural system of the building. What Jenny was allowed to do here in Chicago was to explore some of the rationalist tendencies or some of the rationalistic ideas that he had as an engineer and that he wanted to find an architectural expression for. Here in Chicago, he was given the leeway or the liberty to do that. On the East Coast, he didn't have the same degree of liberty that he had here in Chicago. And so he's making a contribution here by showing how these rationalistic ideas can find their expression in the architectural forms of the buildings. Now, Jenny is going to build a lot of buildings in Chicago, and he's going to take advantage of some of the technological developments that are going to occur through the 1870s and 1880s. During this period of time, steel becomes much more readily available and it becomes cheaper. And steel is an alloy that has superior structural capabilities in compression and in tension. And it's much better than iron. And so this is going to be a new material that is going to get incorporated into structural engineering of the time period, and it's going to change the structural engineering. Here we're taking a look at two different diagrams. One, the diagram of iron construction that we just took a look at. And on the right, we're going to take a look at the structural system that William LeBaron Jenney developed about 1890. And that date is going to be very important. What we see here is a point load system of thermally insulated steel. A couple of changes that we can see between this and what preceded it. First of all, the change in material. It's no longer iron, but it's steel. Secondly, thermally insulated. If we take a look at the iron system, we see very little there that could possibly burn. Right? The iron column isn't going to burn, the girder isn't going to burn, the joist isn't going to burn, the brick vault isn't going to burn, right? It's going to separate one floor to the next. We might think a fire couldn't spread throughout this. And so at the time they thought that this was fireproof. But what they didn't count on was the combustibility of material on each floor of these buildings. Whether it's an office building, whether it's a factory, there was actually a lot of combustible material. And the fires that could break out could burn quite hot. Now, the iron isn't going to burn, but the iron can melt. And through tragic experience, they learned that these buildings could collapse in a fire. And so the way that they developed to offset that was to wrap the main structural supports in these buildings in what's called fireproofing in the diagram, what I call thermal insulation. Sometimes they would wrap them with a brick wall. Sometimes there would be some glazed terracotta tile, relatively thick, that they would just build up around those steel columns. In other cases, they would build formwork and then dump concrete. Whatever it was, the important thing was to separate the steel from any fire that could break out on the floor by something that is going to diminish the heat that actually hits the steel. And so that thermal insulation is there not for its structural capabilities, but rather because it's going to protect the steel from any fire. But this system also had an added benefit. If we take a look at the diagram on the right, and if you take a look at the element there that's labeled girder, you can see that it's extending out from the steel column. As a matter of fact, it's cantilevered out from the steel column. With this new system, there's the possibility of having the exterior of the building not correspond exactly with the steel column. Okay? You could cantilever out a little bit, and then the exterior of the building is going to be hung off of those different floor levels. And so all of a sudden we get what's called a curtain wall. Just as a curtain is a fabric that's hung off of a curtain rod, so the curtain wall of these office buildings were actually hung off of the cantilever that extended beyond the steel column. That's going to open up all sorts of interesting possibilities for the exterior surface of these buildings. But it's also going to mean that the building can be a little bit more structurally efficient. They pretty quickly calculated that if you have the point load system not brought up to the exterior property line of the site, but if you set it back a little bit from the property line and reach the property line with that little bit of a cantilever, you're actually going to get a greater proportion of space to structure than you would the other way around. It was a little bit more efficient. And when you've got buildings that are getting taller and taller and taller, that little bit of efficiency each floor is going to add up. And so what Jenny's system is going to make available is all sorts of possibilities in terms of greater height, but also in terms of curtain wall construction. But keep in mind that date, 1890. For our purposes, we're going to just work with the assumption that any building that was built before 1890 had iron point load system connecting to an exterior masonry frame. And any building after 1890 is going to be a point load system of thermally insulated steel. And that leaves open all sorts of questions about what the exterior envelope of the building is actually built of. Okay? So just keep in mind that with some of the technological developments and with increasing experience, this is going to be one of Jenny's real contributions to architecture in Chicago. Another architect who was important for the development of design in Chicago is H.H. Richardson, an American who studied at the École in Paris. He came back to the United States, made a career for himself designing buildings largely in and around Boston. And if we take a look at the design of his buildings, here we're taking a look at the Crane Memorial Library that he designed, we see something that doesn't have the flat out academic classicism that we might expect of a graduate of the École in Paris. The entrance to this museum is not centered on the building. We don't see a central axis and strict symmetry about that central axis. Furthermore, the architectural language that we see here is not ancient Roman, it is not Renaissance, it is not Baroque. Richardson had the opportunity while he was in France to travel around a bit, and he saw some of the great Romanesque monuments in southern France and in Spain, and he was really inspired by them. And he brought that architectural language back to the United States with him and began working with it. And there were a number of things that people appreciated because of this. Stone, as we know, is a very heavy material. Yet Gothic architecture makes stone look very linear and lightweight. It's kind of working against the inherent quality of the material in order to achieve a very interesting structural system. Richardson was interested in using stone as stone and allowing it to look heavy, to look compressive, and to form a building that looks heavy and compressive. If it's built of stone, why shouldn't it look heavy? And so Romanesque architecture provided him with the historical language where he could explore that. In addition, his appreciation for stone was such that he really played with the different colors of stone and the different textures that you can give to stone. Depending on the stone, you can allow it to have sort of a rusticated surface like we see on many of the pieces of stone here. But stone can also take a very precise edge and a very fine surface, and even some sculptural detail in the stone. And so he was interested in exploring that and allowing that to enliven the building. And in many ways, this was sort of a rational approach to the material, right? Stone is heavy. Let's let it look heavy. Stone is good in compression. Let's show a compressive system here. Some of the other great buildings that he designed, such as Trinity Church in Boston, shows all of these qualities. As we can see in the tradition here, there is a central axis and symmetry about the axis, but we can also identify some of the sources, specifically a cupola of the Romanesque cathedral in Salamanca in Spain, which was the point of departure for the cupola, which was over the crossing in Trinity Church in Boston. So an architect who was really making a very strong contribution to American architecture in the United States at the time. And during the reconstruction of Chicago, he was asked to come in and to design basically a department store, Marshall Field's wholesale store. If we take a look here, we're going to see a building that occupies an entire city block. And in the plan of the building, we can see a point load system of iron that connects to exterior masonry piers. And if we take a look at the exterior of the building, we're going to see something that has a very clear composition to it without a lot of refined architectural detail that's added. The composition has a very clear base, it has a very clear middle, it has a very clear top story to it, tripartite design, right, like we might expect with a classically trained architect. But we can also see the material. It's very clearly built of stone. We can see the structure. You can see in between each of those arched openings, you can see where the piers are. And if you follow the piers vertically on any facade of the building, you can see how it connects all floors of the building and rises, that structural pier rises to the very top of the building. And you can also see how the width of the pier diminishes as it rises from one level to the next. And it's diminishing because the structure doesn't need to carry so much weight as the building rises to the top. There's just less that it needs to carry. And so he's sort of expressing that structural work of those piers by the dimension, by the width of the piers. But let's take a look at how he's enlivening the design. He's enlivening the design by the geometry, by the proportion, by the size of the openings. On the ground floor of the building, we can see a rather squat opening covered with a segmental arch. And then directly above it, the opening is a much taller opening with a semicircular arch. And then on the next level up, not on the next floors up, but on the next sort of structural level up, we see that that opening becomes two openings. Each of those openings, in terms of the proportion, in terms of the width to height proportion of the opening, is similar to the proportion of the one below, but its dimensions are very different, which means that it can be paired up here between those structural piers. And then at the uppermost level of the composition, we see that those arched openings become trabeated, 2 becomes 4, and it sets up a very different rhythm on the uppermost part of the building. All very interesting, right? A very interesting use of what can be considered an historical or a traditional building material in a way that is going to please a lot of people. People who were interested in examining buildings because of their classical principles are going to look at this and appreciate the tripartite organization of the composition. People who are going to come to architecture with romantic or picturesque notions are going to appreciate the eclectic source in the Romanesque architectural language. But even rationalists are going to appreciate this because there is a very clear exploitation of the quality and capability of the material. You can see what the material is, you understand how it's working, both in the structural piers and in the arcuation and even the trabeation here within the building. So a building that ended up capturing everybody's attention. It's deceptively simple, but it was something that captured everyone's attention in Chicago at the time. And furthermore, Chicagoans were kind of flattered by it because at a point in time when people are looking for the associations that they make with architectural form, here they saw these repeated rounded arches and they wondered if Richardson wasn't drawing inspiration from ancient Roman aqueducts. And if he wasn't saying that the businessmen in Chicago are building an empire like the ancient Romans built an empire, not with the military, but rather with economic development. People in Chicago saw those repeated arches and the development that into the larger whole here and wondered if Richardson wasn't drawing inspiration from Renaissance palazzi in Florence. And again, making the association with the banking empires that these different Florentine families had throughout Italy and Western Europe, and the economic empire of the businessmen in Chicago. But in any case, this is going to be a very important example of the sort of exploration that we see in Chicago after the fire. We could take a look at all sorts of buildings after the fire in Chicago and see all of the great degree of exploration that was happening with structure and also with architectural expression. We can certainly see enormously tall office buildings that are articulated with a Gothic articulation. We can take a look at the Rookery. You may recognize the atrium in the Rookery, which is certainly making use of modern materials, iron and glass in an obvious and very efficient structural system in the middle of a building that in many ways seems to be Romanesque revival, right? Sort of mixing it up, experimenting with it. We can see an example of Jenney's work. Here we're taking a look at the first example of a thermally insulated steel point load system, in this case without the exterior curtain wall. In this case, you can very clearly see where those steel columns are located right on the sight line, right on the perimeter of the site. But nevertheless, the first example of his new structural system, obviously from after 1890. And we could also take a look at the Monadnock building in Chicago, a very tall office building that was intentionally designed and built with load-bearing masonry structure. At a point in time when steel was becoming the norm and it would be possible to build a relatively lightweight, extremely tall, very structurally efficient and quick structural system for a building like this, here the designer, the engineer, and the patron were quite happy to build with load-bearing masonry and to express that load-bearing masonry on the exterior of the building. And you can see that very graceful curve as the building comes down to the continuous base. And you can see the thick walls, the thick exterior walls that become even thicker as you go down to the bottom of the building. So a lot of experimentation happening in Chicago. But of course, one of the great individuals involved with the development of the Chicago School is going to be Louis Sullivan. Sullivan was born in the United States, born in Boston, and knew fairly early on that he wanted to become an architect. And as a young man, there were a variety of opportunities open to him for getting his architectural credentials. There was the tried and true apprenticeship method that was the standard in the United States and in Great Britain. But he came of age at a point in time when there were different East Coast universities that were beginning to open architectural departments where the architectural education was modeled after the education at the École des Beaux-Arts in Paris. And so as a young man in the Boston area, he decided that he was going to apply to, be admitted to, and then enroll in the architecture program at the Massachusetts Institute of Technology, which, as we saw, was the first architecture program in the United States affiliated with the university that was based on the education at the École in Paris. It only lasted a year and he became dissatisfied. And so he decided to get his credentials the other way and to seek an apprenticeship. He started out with an apprenticeship in Philadelphia, left that, went to Chicago where there was all of this opportunity, had an apprenticeship in Jenney's office for a brief period of time, but again seemed dissatisfied. And at that point, somebody took him aside and said, look, if you really want to become an architect, you really need to go to the École. And so he went to Paris. He enrolled in a studio that was affiliated with the École for a year. It's not clear that he actually enrolled in the École proper, but he was taking a design studio in a studio affiliated with the École, spent a year there, and then was back in Chicago. And even though he didn't complete a program of study anywhere, by the time he came back, he had a greater direction, a greater purpose, and this time he was able to really make an apprenticeship work for him. And he was going to rise in his apprenticeship and eventually form a business partnership with an engineer known as Dankmar Adler. And the firm of Adler and Sullivan is going to exist for 12 years and is going to be a very important contributor to the Chicago School of Architecture. When we take a look at what Sullivan did as a designing architect in Adler and Sullivan, and then late in his career after dissolving the partnership and going off on his own, we're going to see a variety of qualities to his designs that carry through his mature and his late career. And we know about these not only through examining his buildings, but also because later in his career, he ended up publishing a fair amount. And those publications allow us to read what he had to say and understand how he went about designing buildings. He had a design process that he labeled an organic design process. And perhaps the best way of really explaining what he meant by that is by contrasting that with the typical design process of the école. If someone with a classical background was going to start designing a classical building, the first thing that he or she is going to do on the sheet of paper is to draw a straight line, the axis of symmetry that is going to run through the plan and the elevation of the building, the axis that is going to be the axis of circulation into the building, and then the designer is going to begin to lay out individual geometric volumes along that axis to provide entry into and circulation through the building. None of what I just said is any sort of response to the site, to the climate, to local traditions, even to the building type, right? Sullivan is going to advocate a different way of going about a building, where your consideration of all of these things, the function of the building, the purpose of the building, the site, the local tradition, the materials, the climate, all of this is going to come together and begin to affect the way that you lay out the building and every subsequent design decision. And so just as a plant is going to grow differently based on the soil conditions, based on the sunlight, based on the rainfall, so Sullivan believes a design, an architectural design, should grow and develop differently based on all sorts of different conditions. And so this is what he meant by an organic design process, something that's going to grow and develop differently based upon the individual conditions seen at different places. He's going to focus on the basic design of the building, and by that we can understand geometry and proportion. And for as much as his organic design process was not necessarily a classical design process, so some of his ideas about geometry and proportion do indeed come from the classical background. And as a matter of fact, we're going to see many of his buildings that have an axial organization, and in some cases even a symmetry about a central axis. But in his mind, that was the appropriate response to the site, to the purpose, to the local tradition, whatever, as opposed to being a foregone conclusion like it is in classical design. And then we've got Sullivan's ornament. Sullivan is known today for this beautiful ornament that can be found on many of his buildings. And in an article that he published late in his life, he's going to show us how he goes about designing that ornament. And if we take a look at any of these schemes, we can see the way that he starts at step one with a basic geometric shape. And then step two is a further elaboration of that shape. And then through these different steps, we can see how it becomes more complicated, how the different geometries come together. And then finally, in the later steps, we can see this application of vegetable form onto the basic geometry. All of this is going to result in individual units of ornament that has a lot in common with Art Nouveau. And it's likely that a lot of the Art Nouveau designers in Western Europe saw what Sullivan was doing and took inspiration from what he was doing. But still, it's a very unique way of laying out ornament. And Sullivan, in his early career, just seems to have been able to just produce these really beautiful designs. It just flowed out of his pen. And as his firm became larger and more important, he taught many of his associates how to do this. And so eventually there was a whole team of designers that were producing this Sullivan-like ornamentation. But what's important is that Sullivan believed that ornament ought to be applied onto a building judiciously. There are some cases where it appears to just cover every surface of the building, but he felt that it was more important to apply it to accentuate the purpose of the building. One quick example that we can take a look at of all of this is a department store that he designed in downtown Chicago, Carson Pirie Scott. Now, if we take a look at the exterior of this building, we're going to see over most of it a very frank expression of the structural system, certainly drawing inspiration from some of the ideas that Jenny was propagating in Chicago at the time. If we take a look at the exterior, we can see the basic geometry of the building, and we can also see the way that he addressed the corner with this cylindrical form that rises through all stories of the building. So there's an attention to the proportion of the building here and expressing the basic geometry of the building. But a lot of this is very simple. There's very little detail on most of the building. But if we take a look at the ground floor of the building and the mezzanine level, that's where we're going to see all of this Sullivan-esque ornamentation designed by Sullivan, worked out in drawing, turned into molds, mass-produced, shipped to the site, and then assembled onto the structural frame here. But it's all located on the ground floor and the mezzanine level of the building. However, those offices up on the third, fourth, fifth floor were going to be used, and whatever was going to be happening in them, this was primarily a firm that was a department store. And so they wanted to appeal to the public walking by the sidewalks. They wanted to get their attention, drag them into the store, get them to shop and to buy. And this was the purpose of the building. This, therefore, is the purpose that Sullivan is going to accentuate with his ornamentation. And therefore, it's on the sidewalk level and the mezzanine level where the buying public is going to interact with the building that we can see all of this really beautiful Sullivan-esque ornamentation. So this is where we're going to have to leave it for this lecture. But what we're taking a look at is a particular city where, through a set of circumstances, became the location for a great degree of experimentation in the 1870s, 1880s, 1890s. And we're going to see some very strong rationalistic ideas that end up coming together with some ideas connected to arts and crafts, and also some of the more romantic notions out of Western Europe. And so things are coming together in a very particular way in Chicago, and that's why we pay attention to it as its own individual thing, the Chicago School.